In this lesson, we will learn how to handle fractions where there is a square root in the denominator. Now to set this up, please consider the following scenario. You have just finished working on a question and you are quite certain that the answer is 6 root 3 over the square root of 2. However, when you check the answer choices, none of the choices matches your solution. The reason for this is that it is typically considered bad form to write fractions with a square root in the denominator. So here we want to find an equivalent expression that does not have a root in the denominator. Well, since we have a fraction here, we can create an equivalent fraction by multiplying top and bottom by the same number. Now to eliminate the square root in the denominator, the trick is to multiply top and bottom by the root in the denominator. So let's take our fraction here and multiply top and bottom by root 2. Now to find the resulting numerator, we will multiply 6 root 3 by root 2 to get 6 root 6, and the denominator will be root 2 times root 2, which is root 4. From here, we can leave the numerator as it is, and we can take root 4 in the denominator and rewrite it as 2. We have now accomplished our goal of removing the root from the denominator. Now at this point, our answer still does not match any of the answer choices. This is because we can still simplify 6 over 2 as 3. At this point, we can find the answer in the answer choices. Alright, let's practice this technique. To fix this fraction, we will multiply top and bottom by the root in the denominator. So let's take our fraction and multiply top and bottom by root 6. To find the resulting numerator, we will multiply 11 root 7 by root 6 to get 11 root 42. And the denominator will be 4 root 6 times root 6, which is 4 root 36. From here, the square root of 36 is equal to 6, and when we simplify all of this, we get 11 root 42 over 24. Alright, here's another example. To apply the rule here, we will take our fraction and multiply top and bottom by root 5. On the top, we have 2 root 10 times root 5, which is 2 root 50. And on the bottom we have 3 root 5 times root 5, which is 3 root 25. At this point we can rewrite root 50 over root 25 as root 2, and this is as far as we can simplify our fraction. Okay, now consider this example. How do we fix the denominator here? Well, notice what happens if we take our fraction and multiply top and bottom by 3 minus root 2. Beginning with the numerator, we have 5 times 3, which is 15, and then we have 5 times negative root 2, which equals negative or minus 5 root 2. Now to handle the denominator, notice that we are multiplying two binomials here, which means we must use the FOIL method to find the product. Now if you are not familiar with the FOIL method, you can learn more about it in the algebra module. To apply the FOIL method, we multiply the first terms to get 9. Then we multiply the outer terms to get negative or minus 3 root 2. Then we multiply the inner terms to get 3 root 2. And finally we multiply the last terms to get root 4, which equals 2. From here we can leave the numerator as it is, and in the denominator we can simplify 9 minus 2 to get 7. And we can see that minus 3 root 2 and plus 3 root 2 cancel out, leaving us with just 7 in the denominator. So we were able to take this expression and rewrite it so that there is no root in the denominator. Notice that we accomplished this by multiplying 3 plus root 2 by 3 minus root 2. Notice that these two expressions are identical except one has addition and one has subtraction. We say that 3 minus root 2 is the conjugate of 3 plus root 2. So to fix fractions where the denominator features a binomial with a square root, we can multiply top and bottom by the conjugate of the denominator. Alright, let's take a closer look at conjugates. We will do this by example. To begin, the conjugate of 7 minus root 5 is 7 plus root 5. The conjugate of 3 plus 2 root 10 is 3 minus 2 root 10. The conjugate of 2 plus 5 root 3 is 2 minus 5 root 3. And finally, the conjugate of 4 root 11 minus 8 root 7 is 4 root 11 plus 8 root 7. Okay, now that we have a good idea of what a conjugate is, let's fix one last fraction. To apply our rule here, we will take the fraction and multiply top and bottom by 3 plus 2 root 5. Now to find this product, we will need to use the FOIL method. Beginning with the numerators, when we multiply the first terms, we get root 9, which equals 3. Then we multiply the outer terms to get plus 2 root 15. Then we multiply the inner terms to get root 15. And finally, we multiply the last terms to get 2 root 25. Now on to the denominators. When we multiply the first terms, we get root 9, which equals 3. Then we multiply the outer terms to get plus or positive 2 root 15. Then we multiply the inner terms to get negative or minus 2 root 15. And finally, we multiply the last terms to get negative or minus 4 root 25. Now to simplify the numerator, we can combine these two terms to get 3 root 15. Next, 2 root 25 is the same as 2 times 5, which equals 10. In the denominator, we will leave 3 as it is. Next, these two terms cancel out. And finally, 4 root 25 is the same as 4 times 5, which equals 20. At this point, we can simplify the numerator as follows, and in the denominator, 3 minus 20 equals negative 17. Finally, we can rewrite this fraction with a negative sign in front as follows. Okay, let's summarize. If we have a fraction with one term in the denominator, we can fix the fraction by multiplying top and bottom by the root in the denominator. If we have a fraction with two terms in the denominator, we can fix the fraction by multiplying top and bottom by the conjugate of the denominator.